In each of the three activities that we looked at in this app, we created objects of our utility class database connector, which we're now about to look at, to help us perform the various database operations. Now, in this class, we'll be using some new types from the Android APIs. We've got the content values type, which, as you'll see, we use to assemble the information that will be inserted into the database or updated in the database. We've already worked with the cursor type from the other classes to manipulate the results of a database query. We'll be manipulating a SQLite database in this app, and SQLite is built into Android and allows you to store data in record format using standard SQL queries. There's a class called SQLite Open Helper, which we'll be discussing in just a moment, that helps you open an existing database or create a database if it doesn't yet exist. And we'll also be using a SQLite database cursor factory. In fact, we'll be using the default one as part of the arguments that help us open up the database in the first place. So we've got our class DatabaseConnector here. The name of the database that we'll be creating and or manipulating in this app is user contacts, and we'll be maintaining references to the SQLite database object that we get back and a reference to our own subclass of SQLite Open Helper called Database Open Helper, and we'll refer to that in the constructor, as you can see here at lines 21 through 26, where we create a new object of that class. Now, the four parameters that you see here are the context in which we are manipulating the database, and that's going to be passed in from the activity that actually uses the database connector object. The name of the database, the cursor factory, and null is saying to use the default cursor factory, and then the version of the database that we wish to manipulate. And since this is our first version of the app, we're using version number 1 for the database. Now, before we get into the rest of the details of the database connector class, let's look at the nested class database open helper, which appears down here at the bottom. So let's get that on the screen here. And you can see that our class database open helper extends SQLite open helper. Now let's look at the documentation for class SQLite open helper. You can see that I've gone to its web page here on the developer.android.com website. And I've purposely also set this up to filter by API level 10 because there are some features that you will see in the description here that are not available in earlier versions of the Android APIs. So as I scroll down here, let's go to the constructors and the public methods. The items that are grayed out are features that were added to the API, and you can see when I hover over this that a little tooltip pops up saying that it requires API level 11 or higher. So one of the reasons I'm doing this is as you look through the documentation, you may see certain methods that are quote-unquote deprecated, meaning that you shouldn't use them anymore. However, in certain versions of the API, you don't have any other options. So for example, the first constructor, which is the one that we'll be using in this app, is only available if you're building Android apps that require API level 11 and higher. I'm sorry, the grayed out one is only available for API 11 and higher, so the one that we're using must be used for earlier versions of Android. Now, you can see here that there's a variety of public methods, one of which is for closing an open database object. You also see that we have methods getReadableDatabase and getWritableDatabase. GetReadableDatabase gives us a database that we can use solely for the purpose of querying and getting information. GetWritableDatabase gives us back a reference to a SQLite database that we can also insert, update, and remove data in. Now, there's also some methods that you can override in this class. This is an abstract class, and one of which we're going to be looking at in a moment, the onCreate method. When your app executes for the first time, Android is able to see whether that database exists or not, and if it doesn't, it can automatically invoke the onCreate method to create the database using SQL code, as we'll show you in just a moment. There's also a method onOpen that's called when the database is first opened. So if you have something you need to do in your app because of that event, you can override onOpen. And interestingly, there's also onUpgrade, which allows you to define the SQL code for upgrading the database, perhaps because you've now created an updated version of your app that maybe requires a new column, for example, in the database. OnUpgrade can be used to perform the SQL code that will modify the database layout. Now, there's a couple of other methods here that are grayed out. For example, in newer versions of Android, there's also an onDowngrade. So let's say you go and create a new version of your app, and after you post it in the Android market, you determine that there's a bug in the app and you need to have people go back to the previous version. You can use onDowngrade to revert a database back to a prior version. So let's go back over to our code now. And you can see in the database open helper class, we have a constructor that simply receives all of the information we passed from up above and sends it through to the superclass constructor. And then we define our onCreate method, and you can see we're literally placing the code for creating a table called contacts, and it's going to have an _ID column, which is an integer primary key that's auto incremented, and then it has name, email, phone, street, and city columns that are all of type text. Then to create the actual database, we use the database object that's passed in as an argument to this onCreate method for us, and we simply call execute SQL or exec SQL, which executes some SQL code, and we pass in the create query string, at which point it executes the create table query to create the database. Now for onUpgrade, you can see here that we provided simply an empty body because of the fact that we don't have to upgrade a database in this app. Now let's go back up to the top of the class here and take a look at the remaining methods. So we already looked at the constructor. So our open method is pretty straightforward. We simply say to the database open helper, get writable database, and we store the SQLite database that's returned in our instance variable database. Similarly, for close, we can simply check to make sure that database reference is not equal to null, and then call close on the database object. So those two methods are pretty straightforward, and as you saw in the other activities, we sometimes called open and close from those activities, primarily, for example, in the address book class, where we need to be able to process the cursor before we can close the database. So we manage the opening and closing of the database ourselves from the address book activity. In other cases, we're going to open the database, perform a task, and close it right away because we don't need to keep the database open. So one of those cases is the insert contact method, which receives the data that's going to be inserted, the name, email, phone number, state, and city. We create a content values object, which is a series of key value pairs where each key is a column name and each value is the value to insert in the new record for that column. Now, once we create the content values object, we open the database, we call the database's insert method, and then we close the database. Now, the insert method takes as its second parameter, in this case, null. We're going to be inserting into the contacts table the new contact information, and the purpose of the second argument is what we call the null column hack, or what Android calls the null column hack. If the new contact object that we're inserting into the database is completely empty, then we need to provide as the second argument here the name of a column that is quote-unquote nullable, a column that can contain a null value. Android and SQLite do not allow you to insert a completely empty row into the database table. So if you have the case where you need to do that, you must have one of your columns that can be nullable, and you must specify its column name here in line 54 as the second argument to indicate that it is the nullable column, and a value of null would then be stored in the database at that in that column for that row. For our update contact method, we're going to pass in not only the row ID that needs to be updated, but again all of the information to update. And just as we did up above, we create a content values object of key value pairs with column names and column values. We then open the database, we say to update the database, and then we close the database. Now, as far as the update method is concerned, there are a number of arguments we need to pass. We have to tell it which table to update. We have to give it the content values object that has the information that will be updated. The third argument is a where clause that is going to be executed to determine which contact to update. So we specifically want to update the contact that has the ID value of ID that was passed in to this method as an argument. And then the last argument in this case is the so-called where parameters. We've specified null because we don't have any where parameters. If you're not fully familiar with SQL, where parameters are question marks that will appear in the where clause. The parameters will then be substituted for those question marks. So in SQL, you can specify a SQL query that has parameters by placing question marks where the parameters should go. And then in Android, the update method of the SQLite database object can receive an array of strings that represents the so-called where parameters or where arguments. Next, we have our getAllContacts method. This is called from the address book activity so that we can display all the contacts. And you'll notice for this method, we did not call open and close. We're simply returning the results of a database query operation. That's because in the address book class, we open the database first, then we call getAllContacts and obtain its cursor and use that to populate the list view, and then we close the database. Now you can see here the query method has lots of different parameters. The first argument is the table from which you'll read data. The second argument is an array of strings representing the column names that you wish to select. If you provide null for this one, it's going to select all of the columns, which generally is not what you want to be doing, especially if you have a large database and you're not specifying a where clause to limit the number of rows that come back. So in this case, we're selecting only the ID and the name, and recall that in the address book activity, when we get all the contacts, we display only the name on the screen, and we have the ID available to us so that if the user touches a specific contact in the list view, we can pass that ID over to the view contact activity so that it in turn can call getOneContact for the appropriate row ID to get the information for that contact. Now, the remaining data that's required by the query clause, the next item is going to be the where clause, similar to what we did up here in the update method. The next item would be the arguments to the where clause if there were any. Then we have the so-called group by clause, and in this case we're not grouping the results into groups, so we don't need a group by clause. And if the group by clause is null, then the having clause, which is the next one, would also have to be null. But if we do have grouping being performed on the results, you can also have a having clause that says how to do the groupings. And then finally we have the name column being used as the order by clause. So basically what we're saying with this database query is we want to get from the contacts table all of the IDs and names ordered by the names of the contacts. Then we have our getOneContact method. Similar to what we did in getAllContacts, we have a database.query call. We're going to use the integer, or the long integer ID rather, to specify which contact to get. So we go into the contacts table. We specify null for the columns to get, because in this case we really do want to get all the columns. We're selecting one full row of the database. Then we have our where clause, which is going to say get the contact with the specified ID value. And then for all of the other arguments, we supply null because we don't have where arguments, we don't have a group by clause, we don't have a having clause, and we don't need to sort the results when there's only going to be one result for the unique ID specified. And then finally, we have our delete contact method, which receives the ID of the record to delete. We open the database, delete the record, and close the database. And as you can see here, delete takes the table to delete from, a where clause specifying what to delete, and potentially some where arguments as well.